Number 11. Solve this problem. 3/4 plus 1/2 x equals 1/4 x. Okay, so now we could solve this with fractions. We would change that 1/2 into fourths, 2/4, and add, and then do whatever we need to do there. We can do it that way. But sometimes these fraction problems have like 3 different denominators, and it's much easier to solve a somewhat complicated fraction equation by multiplying through by the least common denominator. So that's what we're going to do here, just as an example. Okay, so the least common denominator for 4 and 2 is 4. Both numbers have to be in each, it has to be in the 2 times table, it has to be the 4 times table, and it's got to be the least one that they'll both divide into. 4 will divide into 4 evenly, 2 will divide into 4 evenly. So, and 4 is the lowest one. If you try 2, 4 will not divide into 2 evenly. 4 into 2 is 1/2. See, so that doesn't work. So it's got to be 4 or a multiple of 4. The least common would be 4. Alright, so we'll multiply both sides of the equation by 4. Had a little problem there. I don't know if you noticed. Okay, so we'll take it each one individually. Now what we could do is we could put a dividing line over on one side and we could just do each of the fraction multiplications on one side. So we've got 4 over 1 times 3/4. Okay, so if we don't cross cancel, which I always do, I always cross cancel. If I cross cancel, 4 goes into 4 one time, our answer would be 3. But if you don't cross cancel, you've got, I better do it down here, 4 over 1 times 3 over 4 equals, 4 times 3 is 12. That would be 12 over 4. 12 divided by 4 equals 3. So you see you get the same thing. So 4 times 3/4, so we'll stick that up in here. Our first one is 3 plus our next one. Now we've got 4 times 1/2 x. Okay, so we'll put 4 over 1 times 1/2 x. Again, if you don't cross cancel, you're going to get 4. That's supposed to be an equal sign. It looks like terrible. All right, 4 over 2x. All right, so 2 into 4 is 2. We give us 2x. So plus 2x, and that equals 4 times 1/4 x. So let's do that one. Or 1/4 x times 4, or 4 over 1, which give you 4 over 4 for those people who don't cross cancel again. 4 into 4 is 1. Okay, so we get 1x, or just plain old x. Now the problem has just suddenly become a lot simpler. Now we'll want to get our x terms on one side and our numbers on the other. So this time I'm going to start with our x terms. I'm going to subtract an x from both sides. So we've got 3 plus 2x plus a negative x equals x plus a negative x, or x minus x. That gives us 3 plus x equals 0. Don't get scared if one side turns out to be 0. It's a number. Okay, so now we want to get our x alone. This is not x equals 3, as you will see in a second. Okay, so we're going to add a negative 3 to both sides. Okay, 3 plus a negative 3 plus x equals 0 plus a negative 3. That gives us x equaling a negative 3. Remember what I said back here. This does not turn into x equals 3. because we have to subtract that 3 out, so we have x equals. So here it gives us x equals a negative 3. Number 12, solve the equation. 2x minus 6 equals 2 parentheses x minus 3 close parentheses, or 2 times x minus 3. We could say it's the difference of x and 3, 2 times the difference of x and 3. That's how we would write it out if we were writing it out in words. So if we, let me back up. Let's say I wanted to write 2x minus 6 equals 2 times that parentheses x minus 3. I wanted to say it in words. I would say 2 times a number minus 6 equals 2 times the difference of the same number and 3. Okay, but all that aside, let's solve this problem. So we look at the left and we look at the right side of the equation, the equal sign, and we see there's nothing to do on the left side. It's already as simple as it can be. The right side, there's the distribution. So we want to distribute the 2 again over the x and over the 3. So left side stays the same, 2x minus 6. The right side becomes 2x minus 6. Okay, so now notice, 2x minus 6 equals 2x minus 6. Both sides are equal. That is a sign when both sides turn out to be equal when you're solving an equation, is that any number will work for x. So the solution is all real numbers. All real numbers. We could keep going. Let's say we add a negative 2x to both sides. We have 2x minus 2x minus 6 equals 2x minus 2x minus 6. Okay, the two x's cancel themselves out, and we have negative 6 equals a negative 6. I mean, you might end up getting down to the point where you have just two numbers. And actually, we could add 6 to both sides. Why not? 6 plus 6, and then we end up with 0 equals 0. So what it amounts to is that no matter what you do, you're going to end up with one side equaling the other. So that means you stick a number in there. You can put in a negative billion, you could put in 2, you could put in the square root of 5. It doesn't matter what you put in for x. They'll always come out being equal. So that's all. The solution to this is all real numbers. Okay, number 13. Find the area of a circle. Number 13, find the area of the circle. Now that 6 meters refers to the diameter. The diameter is the distance all the way across the circle. From the widest part, between the two widest parts, it goes through the center. The diameter goes through the center of the circle to the other ends. The radius, however, the radius is only halfway. So the radius would just be this part, and that would be r. So the diameter would be d, and the radius is r. Okay, so if our diameter equals 6 meters, then our radius would be half of that. The radius would be 3 meters. Okay, now the area of the circle, in general, I like to draw it like that. Area equals pi r squared. The circumference of the circle, which is how far around. The area of the circle is the whole inside. So the area of the circle is that whole surface, the whole inside surface. It would be in square units. You know, in this case, it would be square meters. 6 meters across. That's about 6 times, a little more than 6 times 3. It would be like 18 feet across. See, so anyway, so it would be a number of square meters. So our area equals pi r squared. Our r is 3, so it would be 3 squared. So that would equal pi times 9, or another way, most people would put 9 pi. Now, oftentimes we'll assume that pi is 3.14. I mean, pi can be taken out to millions of places, so it's not exactly 3.14, but for us, for our purposes, pi equals 3.14. It's accurate enough for us. Okay, so our answer would be 9 times pi as 3.14. This equals 28.26. Write that again, 28.26. You can do this on your calculator. Number 14, solve the equation for h. A equals 1/2 b times h. This would usually be written A equals 1/2 b h. Because b times h is the same as bh. But it's a hint. It's a hint. This is to solve the equation for h. So we want to solve the equation for h. So to do that, oh, I didn't think it would erase everything. Let me put that back in, BH. If I want to solve the equation for h, I've got to get h alone. And to get h alone, I've got to get rid of that b and get rid of that 1/2. But I can't just erase them, because then it wouldn't be equal anymore. I've got to do the same thing to both sides of the equation. So that's all you think of. When it says to solve for h, or solve for y, or solve for whatever, you want to get that number alone, but you have to do the same thing to both sides. That's mathematically correct. You know, so I want to get rid of the b, and I want to get rid of the 1/2, and I want to have h equaling something. Okay, so to do that, let's just get rid of the b first. Let's divide both sides by b. Or we can multiply both sides by 1/b, the reciprocal of b. Either way, it gets rid of it. So we'll divide this side by b, and we'll divide this side by b. The b's cancel out over here, because b over b is 1. b divided by b is 1. So now we have a divided by b equals 1/2 h. Now we get rid of our 1/2. Now we could divide it by 1/2. That's true, and 1/2 divided by 1/2 is 1. But we could also multiply 1/2 by its reciprocal, or if you flip the fraction over, you have its reciprocal. So we can multiply 1/2 by 2, 2 over 1, or 2. So let's do that. We'll multiply both sides by 2. We'll go 2 times a divided by b, and 2 times, or 2 over 1, same thing, right? Times 1/2 h. 1/2 times h. Okay, so these 2 times 1/2, now for you folks that do not cross cancel, now we have over here, we'll multiply the 2 times the top over here, 2a over b equals, no, I'm going to take this over on the side, okay? Take this over here. So I've got 2 over 1 times 1 over 2. 2 times 1/2. I would get 2 divided by 2, which equals 1. Okay, or 1h, or just plain old h. I'm done. There's my answer. 2a over b. Number 15, solve and graph the inequality. Alright, it's negative 8x is less than 40. Okay, now dealing with inequality. Let's just think about this for a second. If we had, let's say 2 plus 3 is less than 2 plus 4. Let's say we had that. Okay. We could subtract 3 from both sides. So we'll go 2 plus 3 minus 3 is less than 2 plus 4 minus 3. So that would give us 2 is less than 2 plus 4 minus 3 be plus 1. So 2 is less than 3. which makes sense. It makes sense that 2 plus 3 is less than 2 plus 4, and it makes sense that 2 is less than 3. And we could do, so anything we do, we could add, we could subtract. I could add 5 to both sides. That's all right. Then I've got 7 is less than 8. And I can divide both sides by 7, which isn't so great. Let's see. What if I multiply? I'll multiply both sides by 4. Let's do that. 4 times both sides. Okay, so we have 28 is less than 32. That works. Okay. But what if I said, okay, I'm going to divide both sides by 4. Okay. Or let's say I'm going to divide both sides by 2. If I divide both sides by 2, divided by 2, divide by 2, then what I'm going to get is, on the left side, I'm going to get 28 divided by 2 is a negative 14. On the right side, 32 divided by 2 is a negative. Now, negative 14 is not less than negative 16. So this should indicate to you that if we divide or multiply by a negative number, it suddenly changes the sign. Instead of that, instead of negative 14 being less than negative 16, it's actually greater. So we turn the sign around. So negative 14 is greater than a negative 16. So anytime you the only difference of dealing with the inequalities as opposed to dealing with an equation is that when you divide or multiply by a negative number, you've got to turn the sign the other direction, because you see what happens. So going back to our original problem, we've got a negative 8x is less than 40. So we can divide both sides by a negative 8, just like we would if it was an equation. And so these two 8's, negative 8's, cancel out, and we get x. On the right side, 40 divided by a negative 8 is a negative 5. But like I said, we're divided by a negative number here, so we have to turn the sign around. Now it's x is greater than a negative 5. Our solution set then for this number, this problem would be x, the set such that x is greater than negative 5. Like that. If I was going to graph it, graphing it, I use the parentheses, and because it's greater than, and I'll put an arrow in the direction that x is. So x is greater than negative 5, graphed. This is a more complicated one, number 16, an inequality to solve and then write the solution set and then graph. But it doesn't mean you have to freak out. It's just got a little bit more to do. So we look at both sides and we simplify both sides. That's the first thing. It's the problem is negative 7 times the difference of 1 and x, or 1 minus x, plus x is less or equal to a negative, there's something missing, a negative 3 minus 4x. So actually we have two distributions here. We've got the 7 that we distribute times the 1 and times the x, and then we've got the negative. The negative is the negative 1 times the 3 and times the negative 4x. So negative 7 times 1 is a negative 7. Negative 7 times the negative x is a positive 7x. And then nothing happens to this x, so we'll just keep it. Is less or equal to negative 1 times 3 is a negative 3. Negative 1 times the negative 4x is a positive 4x. Okay, so now we go and look at both sides and simplify. There's nothing to simplify on the right, because we can't combine that negative 3 and that 4x. On the left, though, we have two x terms. So 7x plus x is 8x. So we'll change this. Negative 7 plus 8x is less than or equal to negative 3 plus 4x. And then just like if we were dealing with an equation, we want to get our variables on one side and our numbers on the other, our constants on the other side. So let's. I'm going to start with the variables. I'm going to subtract or add a negative 4x to both sides to get that 4x out of the right side. So we've got negative 7 plus 8x minus 4x is less or equal to negative 3 plus 4x minus 4x. Okay, and that gives us a negative 7 plus 4x is less or equal to negative 3. Okay, so now we're going to get that negative 7 out of there before we do anything else. So to do that, we'll add a 7 to both sides. Negative 7 plus 4x is less or equal to negative 3 plus 7. So now we end up with 4x is less or equal to 4. Getting there. And then divide by 4, divide by 4. X is less or equal to 1. So our answer is x is less or equal to 1. So our solution set is x such that x is less or equal to 1. And then if we graph this, we'll use, since it's less or equal to, we'll use the bracket. And x is less or equal to, so it's going, the bracket's going to go in the direction that the x is. Just like that. Number 17. Use the graphing calculator to graph the following equation, sketch the resulting graph. Actually, it's not, it's right, it's the equation right there. Okay, it's not following. Alright, so when you want to graph in your graphing calculator, first you put the equation in y equals mx plus b form, or the slope-intercept form, which that's what it is in already. And then what you do is you push that button right there that has the y equals on it. When you push that y equals button, you're going to see the stuff up here. You're going to see all those different y1, y2, y3, y4. So you can actually plot a whole bunch of graphs at the same time. But we're just going to be plotting one right now. So what we do is we're going to put in 3/5 x. So you put 3 divided by 5, and then you put x, and then minus, and then you put 2 divided by 3 for 2/3. Then what you do is you push the graph button, which is right there. And of course on the one I've graphed it on is right there. And then you see your graph, and then you plot the graph. Okay, I plotted the line. You may want to, when you're trying to plot a line from the calculator, you may want to just look back at your equations to see where the y-intercept is, which is negative 2/3, which is right here, and then count the slope out just to kind of get your line in the right spot, because it doesn't always look the same on the graph as it does on the graphing calculator. It looks, you know, a little bit different, but anyway, you can see it's the same. The one on the graphing calculator does go below the origin, because that's where the y-intercept is. It's right there at negative 2/3. And if you count up, 3 from there, be 1, 2, 3, and then you go over 5. You'd get to about there. See, so you want your line to kind of cross where mine does. Anyhow, it doesn't have to be perfect because you're trying to copy from the graphing calculator. Number 18, graph the linear equation by plotting the x and y intercepts. Okay, so we got to find the x and y intercepts. Hopefully you remember how to do that. So we can find the y-intercept by putting 0 in for x. So we've got 4x minus 2y equals a negative 12. So when x is 0, it's got the x is 0 all along here. See, so somewhere along here is the y-intercept for this equation. All right, so we'll put in 0 for x. So we have 4 times 0 minus 2y equals negative 12. The 0 wipes out that 4, so we have negative 2y equals negative 12. Divide by 2. Well, no, divide by negative 2. Got to get rid of the negative. Got to have a positive y. So y equals, and negative 12 divided by negative 2 is positive 6. Okay, so the y-intercept is positive 6. So the y-intercept is a positive 6. Now let's find the x-intercept. Let's put a 0 in for y. Where y is 0, the intercept will be somewhere along that line, along the y-axis. That's the x-intercept. For x minus 2 times 0 equals negative 12. Again, the 0 wipes out that y, and we have 4x equals a negative 12. Divide by 4, divide by 4, and we get x equals a negative 3. Okay, so there's our x-intercept right there. And there we have our line going through the y-intercept, which is a positive 6, and the x-intercept, which is a negative 3. Number 19, graph the linear equation, show your method. Okay, so we have our choice here. We could do it like we did in the last one, where we use the intercepts, right? So we'd either stick in a 0 for x and we stick in a 0 for y. We find the intercepts. Or we could use a table, or we could put it into slope-intercept form and plot it that way. So let's use a table first. And to do that, it's actually easiest if we put it in slope-intercept form first to do that. So we're going to do that. So to do that, we have to get our y alone. There's our y. I want to get him alone. So we'll subtract, we'll add a negative 3x to both sides. Okay, so negative 3x plus 3x minus y equals 5 plus a negative 3x. Okay, so that gives us negative y. I have to move over a little bit. Negative y equals 5 minus 3x. Okay, I'm going to switch where the 5 and the negative 3x are to put it into that slope-intercept form. So I'm going to put negative y equals negative 3x plus 5. Okay, but now to get it so it's y, not negative y, I have to multiply both sides by a negative 1, or divide by negative 1. Doesn't really matter. So I think I'm going to multiply by negative 1. Both sides, negative 1. Okay, so that turns this into y, this into a positive 3x, and that into a negative 5. Now we'll make a table. There's our x, there's our y. And because we have it in the slope-intercept form, it's easier to pick out good x's and good y's. But we might as well start out with x being 0, because that gives us a y of negative 5. Okay, and then let's try x as 1. So 3 times 1 is 3, and 3 minus 5 is a negative 2. Of course, you can write these out on the side and solve these things on the side, right? You go 3 times 1 minus 5 is 3 minus 5, which equals a negative 2. Then let's try 2. When x is 2, 3 times 2 is 6. 6 minus 5 is 1. Okay, so now we have 3 points, and I will plot them. So we have 0, 5. So 0, 5, that's our y-intercept. And then we have 1, negative 2, 1, negative 2, and we have 2, 1. So 2, 1. So now we've got our 3 points. We can draw the line. And there we have our line going through the 3 points. Okay, the other way to do it is to just use our slope-intercept form, which we're going to do now. Okay, so here's our slope-intercept form. The intercept is a negative 5, which we already have graphed right there. And then we'll do our slope. Our slope is 3 over 1. M equals 3, so we make a fraction out of it, 3 over 1. So the rise part is a 3 and the run part is 1. And they're both positive. So we go up 3, 1, 2, 3, and we go over 1. Well, luckily we already have a point there, so we'll just draw our line. That's the best I can do on this funky stylus. Anyway, so there's our answer. Number 20, graph the linear equation. So you see our equation is y equals 5. So where does y equal 5? Well, y equals 5 right here. Okay, so what you'd want to do is just put a dot there. Y equals 5. And then y is always 5. So no matter what x is, x could be 3, 5, 7, 8, 9, x could be any of these, it's always going to be 5. So there's our line going through y equals 5. Those are really easy. You don't want to get those wrong. When it's x equals 5, of course, x equals 5 is, here's where x is 5, right here. So this would be this one. Or x equals negative 4. It would be that one.